In this segment, we'll talk about how to experimentally find the two coefficients of thermal expansion of a unidirectional lamina. So we want to experimentally find the value of the coefficient of thermal expansion parallel to the fibers, which is called the longitudinal thermal expansion coefficient, and then of course perpendicular to the fibers, and that is called the transverse coefficient of thermal expansion. So let's go and see how we go about doing that. So here are the formulas which we found out for alpha 1 and alpha 2 when we were modeling the problem. So I'm just showing that for completion purposes that, hey, we already derived these formulas for alpha 1 and alpha 2. Now we're going to see that how can we do this experimentally. So this is alpha 1, which is in the direction parallel to the fiber. This is alpha 2, which is in the direction perpendicular to the fiber. This is called the longitudinal thermal expansion coefficient, and this is called the transverse thermal expansion coefficient. So let's go and see that how that is done experimentally. So here you are seeing a schematic of how the thermal expansion coefficient is found by using experiments. So the figure which you are seeing here is actually a unidirectional graphite epoxy laminate. It's made of 8 plies. You don't take just a single layer and try to find out what the thermal expansion coefficient is because it don't be stiff enough. So you take about 8 ply laminate, which will be 8 times 0.005, which is 0.04 inches in thickness approximately. And then what you're going to do is you're going to put a temperature sensor, which is right here. And then you're going to have here, which is going to measure the strain in direction 1. And this one here is going to measure the strain in direction 2. So that's how we're going to be able to find alpha 1 and alpha 2. These test specimens measure about 2 inches by 2 inches. And as I mentioned, they are comprised of 8 ply laminated unidirectional composite. So the two strain gauges are placed perpendicular to each other, as you're seeing in the figure here, and of course along with the temperature sensor. The specimen is then subjected to controlled temperature increase. So we go through a delta T, and when we go through a delta T in an oven, what's going to happen is that you're going to measure the strain and the temperature data as you go along. And then you're going to plot these two strains. You're going to plot epsilon 1 and epsilon 2 as a function of delta T. And then you'll be able to take the slope of those plots to be able to figure out what alpha 1 and alpha 2 are. Let's go and see how that takes place. So these are the typical graphs which you are seeing here. This is the induced strain. This is epsilon 1 and this is epsilon 2. And as you're finding out here is that you have these several data points which have been taken at different temperatures as it goes from about 30 degrees Celsius to about 180 degrees Celsius right here. And this one is epsilon 2, although it's not exactly linear, but we can assume it to be linear in order to get epsilon 2. And if you remember your computational methods course or a numerical methods course, how we're going to find out what the equation of this slope is, or what the value of the slope is by doing linear regression. So the linear regression itself is going to help you to figure out, hey, what is alpha 1 and alpha 2. And that's all you're going to do. You're going to basically do a regression between, let's suppose, hey, what is epsilon 1 and what is delta t? And once you have plotted those points and whatever turns out to be the slope of that will give you alpha 1. And in this case, you're finding out that the alpha 1 is a negative quantity. As you can see that the slope is almost negative. So you get this, and for alpha 2, you get this as the value. And now keep in mind that you have to learn about linear regression. So when you are learning about linear regression, make sure that you are learning about two types of models. One is the y is equal to a naught plus a1x model, and the other one is y is equal to a1x model. The formulas for these two models are different, and that's what's going to help you to figure out, hey, how to calculate these slopes. And that's the end of this segment.